Welcome to ZICA Academy YouTube channel. In this lecture, I want to examine asset replacement decision, taking time value into account. This is my second video on replacement decision. If you are coming across my lecture for the first time, please make sure you like the video and also share it with others. If you are a returning subscriber, I say thank you for being part of this channel. So replacement, taking time value into account. So when we say time value means discounting. It means discounting, that is to calculate the present value. That is the meaning of time value. So if you are taking the time value of money into consideration, so that means you need to discount the cash flows. So to discount the cash flows, you'll be given the cost of capital. Cash flows comprises, so cash flows for asset replacement decision comprises, number one, the capital cost of the asset, that is the purchase cost of the asset, This will be treated as an outflows. It will be treated as cash outflows in year zero. So the purchase cost of the asset should be treated as cash outflows in year zero. By cash outflows, it means the money is going out of the entity. You treat it as a negative amount. You have it as minus. Number two, so we have the maintenance and operating cost of the asset. The maintenance and operating cost of the asset. The annual maintenance cost or operating cost of the asset should be treated as an outflows in the year in which they are incurred. Outflows in the year in which the costs were incurred. You treat those costs as an outflows in the year they were incurred. Number three, we have the scrap value. Scrap value. Another word for scrap value is the residual value. This is the resale value of the asset. Resale value of the asset. So whichever one you see, scrap value, residual value, resale value of the asset, they all mean the same thing. So this will be treated as an inflow. It will be treated as an inflow in the cycle in which they are earned. You treat the resale value or the scrap value of the asset as an inflow in the replacement cycle in which they are earned. These are the cash flows associated with asset replacement decision. What are the steps for solving asset replacement decision, taking time value into account? The first step is to identify the cash flows. Identify the cash flows. Cash flows. I've itemized the component of cash flows above. I've itemized them. Identify the cash flows of the asset in each of the replacement cycle. You identify the cash flows of the asset in each of the replacement cycle. So what are the cash flows associated with each of the replacement cycle? That is the first step. Second step is to calculate the present value of the cost for each replacement cycle. Calculate the present value of the cash flows in each of the replacement cycle. To calculate the present value. Then the next step, step 3, is to calculate the equivalent annual cost for each replacement cycle. Calculate the equivalent annual cost for each replacement cycle. Equivalent annual cost. Equivalent annual cost. What do we mean by equivalent annual cost? Equivalent annual cost equals to the present value of cost over one replacement cycle. Present value of cost over one replacement cycle divided by the cumulative discount factor over the same cycle. Divided by the cumulative discount factor over the same cycle. You calculate the cumulative discount factor. So you divide the present value of the cost by its cumulative discount factor. That will give you the equivalent annual cost. This step number 4. Select the replacement cycle with the lowest equivalent annual cost. Select the replacement cycle with the least equivalent annual cost. Go for the one with the least. Now, discount factor, the formula is 1 plus R raised to power minus N. So if it is cumulative, you can sum up the discount factor for each year, or you make use of the annuity formula. Cumulative discount factor equal to 1 plus R raised to power minus N over R. Let's assume you want to calculate cumulative discount factor over 4 years, e.g. over 4 years. If the discount factor, if the cost of capital is 12%, so you have 1 minus 1 plus R is 12%, 2 plus 1, 2, raised to power minus N. So if it is over 4 years, your N is 4 over R, 0.12. So which is 1 minus 1.12 raised to power minus 4 over 0.12. So if you evaluate this, so you have 3.037. This is the cumulative discount factor over 4 years. But if it is discount factor for the 4th year, you take your arrow to be 4 here. So it will be 1.1 raised to power minus 4. So this one will be 1.12 raised to power minus 4. That gives us 0.6355. This is the discount factor for the fourth year. But this is the cumulative over 4 years. Or you calculate it year by year, then you add it together. You add for the 4 years together, it will give you this. So these are the steps for solving the replacement decision where time value is involved. Now I want to take question as work example. Keep watching. Example. Long is considering its replacement policy for a particular machine. The machine has purchased cost of 30,000 naira and a maximum useful life of 4 years. The following information is also relevant. We have here maintenance or running cost of machine. Then we have scrap value if sold at the end of year. Year 1, 4,000 and 15,000. Year 2, 5,000, 10,000. Year 3, 6,500 and 6,000. Year 4, 8,000 and 10,000 and 1,000. Long's cost of capital is 12%. Calculate the equivalent annual cost of each replacement cycle and recommend which cycle should be chosen. Now, let's have the solution to the question. Remember, I've told you the first step is to calculate the present value of each of the replacement cycle. So to calculate the present value, you identify the cash flows. We have here, let's say replace every year. If the asset is replaced every year. So we have here items and cash flows. So year 0, I've told you are going to have the capital outlay, which is the cost, the purchase cost of the machine. So we have purchase cost of the machine. And I've told you that will be treated as an outflows. And how much is it? The machine has a purchase cost of 30,000 naira. The purchase cost is 30,000. So that will be treated as an outflows in year 0. Then year 1. The machine has a maintenance cost of 4,000 naira in year 1. Maintenance or running cost. Maintenance cost. And that amounted to 4,000 naira in year 1. At the end of the year 1, the machine has a resale value. Resale value. Maintenance cost is also a cash flows. It's outflows. No, you are going to pay for maintenance, so the cash is leaving the entity. It's a cash outflows. Then the scrap value, the resale value. The scrap value, if sold at the end of year, if it is sold at the end of year 1, it will be sold for 15,000 naira. That is an inflows. The entity will receive cash if the machine is sold. Then we now have discount factor at what is the cost of capital or the discount rate. Now, back to the question. Long's cost of capital is 12%. The cost of capital is given to be 12%. So you calculate the discount factor at 12% cost of capital. Remember, I've told you the appropriate discount factor for a year is 1 plus R raised to power minus N, where R is 12%. 12%, 12 divided by 100, that will be 0.12. 1 plus 0.12, that will be 1.12 raised to power minus N. So if N is 1, so you depress your calculator, 1.12 raised to power, in my own calculator, in the calculator I'm using, this is raised to power x raised to power, that is y raised to power x. But in some calculator, scientific calculator, it is written like this. You depress the key that contains this symbol. So, raised to power minus 1 equals to 0.8929. I use plus or minus key to insert minus sign in this calculator. But if you are using the calculator that contains the exponential function like this, you depress the minus directly. So for year 1, so it is 0.8929. For year 0, it is always 1. So what is the present value of that? So 30,000 times 1, that is 30,000. Outflows, 4,000 times 0.8929. That gives us 3,572. 3,572. Then 15,000 times 0.8929. That gives us 13,394. You know, the received value is an inflows. So minus 30,000, and this is also minus 3,572, and plus 13,394. We have 20,178. That is the present value if it is replaced every year. Then what will not be the annual equivalent cost if it is replaced every year? Remember, the cumulative discount factor for 1 year is 0.8929. 0.8929 for 1 year. So if it is this, let's divide 20,178 divided by 0.8929. That gives us 22,000. That is equivalent annual cost. And that is 22,598. That is if it is replaced every year. Now, if it is replaced every 2 years, now, replace every 2 years. So we have year, we have items. In year 0, we have purchase costs. And the purchase cost remain 30,000 as usual. In year 1, we have maintenance cost of 4,000, and in year 2, maintenance cost of 5,000. 4,000, which is an outflows, maintenance cost. In year 2 also, maintenance cost of 5,000 as well, outflows. Then, at the end of year 2, this machine will be sold for 10,000. Year 2 again, we have received value. To be sold for 10,000, and that is cash inflows. Discount factor at 12% cost of capital. So in year 0, that is always 1. In year 1, so 1.12 raised to power minus 1, that remains 0.8929. 0.8929 for year 1. Year 2, so where you have n in the formula, remember the formula I gave you is 1 plus r raised to power minus n. So, and this is 1.12 as before raised to power minus n, where n is 2 now. So you have 1.12 raised to power minus 2. That gives us 0.8929. 7972. And this is year 2, 0.7972. What is the present value of that? 30,000 times 1, we have 30,000. 4,000 times 0.8929, that will be 3,572. 5,000 times 0.7972. That gives us 3,986. 3,986 for the receipt value. We have 7,972. What is the present value of that? The PV of our cash flows, we have 3,000. We have minus 30,000 minus 3,986. Then 3,572 plus 7,972. That gives us 29,586 outflows. This is outflows. So, equivalent annual cost now. That would be the cumulative discount factor for 2 years. This is year 1 plus year 2. Let's add 0.8929 plus 0.7972. Cumulative discount factor for 2 years is 1.6901. By the time you add the discount factor for year 1 and year 2, so it gives you this. So divide the present value by the cumulative discount factor. Cumulative discount factor. Therefore, equivalent annual cost now will be 29,586 divided by 1.6901. So we have 17,505. 505. This is the equivalent annual cost if the machine is replaced every 2 years. If it is replaced every year, the equivalent annual cost will be 22,598. Now, if this machine is replaced every 3 years now, replace every 3 years. We have year items. Year 0, we have purchase cost. The cash flows. The purchase cost is given to be 30,000. In year 1, we have the maintenance cost of 4,000, and in year 2, maintenance cost of 5,000. Maintenance cost. Year 1, 4,000. In year 2, maintenance cost of 5,000. In year 3 now, we also have maintenance cost. In year 3, the maintenance cost of the machine is 6,500. 6,500. Outflows. In that same year 3, we have received value of the machine. If the machine is to be sold at the end of the year 3, it could be sold for 6,000. The received value is 6,000. 6,000, which is an inflows. The discount factor, the cost of capital remains 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. 12%. In year 1, as calculated earlier, is 0.8929. 0.8929. In year 2, as calculated before, is 0.7972. 0.7972. Now, in year 3 now, so 1.12 raised to power minus 3. That gives us 0.7118. 0.7118. This is also year 3. 0.7118. What is the present value of that? 30,000 times 1. We have 30,000. It's an outflow. That is why we put it in bracket. 4,000 times 0.8929. That gives us 3,572. 3,572. Then 5,000 times 0.7972. And we got 3,986. 3,986. In year 3 now, 6,500 times 0.7118. That gives us 4,627. 4,627. Then in the same year 3, for the received value, the present value of that 6,000 times 0.7118. That gives us 4,271. 4,271. So what is the present value of the associated cash flows? Minus 30,000 minus 3,572 minus 3,986 minus 4,627. Then we have plus 4,271. So that is total 37,914 outflows. Then what is the cumulative discount factor for 3 years? 3 years. Year 1 to 3. Let's add the discount factor. We have 0.8929 plus 0.7972 plus 0.7118. That is total 2.4019. 2.4019. Now, what is the equivalent annual cost of the machine? You divide the present value by the cumulative discount factor. So that will be 37,914 divided by 2.4019. So we have 15,785. 15,785 negative. Then, if this machine is replaced every 4 years, replace every 4 years. We have year, items, cash flows. Year 1, purchase cost, and that amounted to 30,000 naira outflows. in year 0, purchase cost. Then in year 1, maintenance cost, and that is 4,000. Outflows in year 2, we have maintenance cost, and that is 5,000. In year 3, we have maintenance cost, and that amounted to 6,500. In year 4, we have maintenance cost of 8,000 in year 4. Then in the same year 4, the machine has a resale value of 1,000. The resale value of the machine at the end of the year 4 is 1,000. Year 4, resale value of 1,000. That is an inflow. The discount factor remains 12%. For year 0, it's always 1. And for year 1, as calculated before, is 0.8929. 0.8929. For year 2, as calculated before, is 0.7972. 0.7972. For year 3, as calculated before, is 0.7118. 0.7118. Then for year 4, the formula still remains the same: 1 plus r raised to power minus n. If r is 12%, which is 1.12, raised to power minus n, our n is 4. So for the 4th year, so 1.12 raised to power minus 4, that gives us 0.6355. 6355. And this is also year 4. So we have 0.6355. So what is the present value of that? 30,000 times 1, it remains 30,000. So 4,000 times 0.8929, that is 3,572. 5,000 times 0.7972, we have 3,986. 3,986. For year 3, 6,500 times 0.7118, we got 4,627. 4,627. For year 4, 8,000 times 0.6355, that gives us 5,084. 5,084. For year 4, 1,000 times 6,000, 1,000 times 0.6355. So we have 636 inflow. So what is the present value of that? So we have minus 30,000 minus 3,986 minus 4,627 minus 5,084, then plus 636. That is totaled 43,061. So, what is the cumulative discount factor for 4 years? That is, you add from year 1 to year 4. The discount factor for year 1 to 4. Let's sum it up. 0.8929 plus 0.7972 plus 0.7118 plus 0.6355. That is totaled 3.0374. Therefore, equivalent annual cost will be 43,061 divided by 3.0374. So we have 14,177. So, replacement cycle, then equivalent annual cost. If it is replaced every year, every 2 years, every 3 years, and every 4 years, what is their equivalent annual cost? If it is replaced every year, the equivalent annual cost is 22,598. 22,598. If it is replaced every 2 years, the equivalent annual cost is 17,505. 17,505. 17,505. If it is replaced every 3 years, equivalent annual cost is 15,785. 15,785. If it is replaced every 4 years, we have 14,177. 14,177. These are the costs. Now, which of the replacement policy do we recommend? Decision. I've told you go for the cycles with the least equivalent annual cost. So, cycle 4 has the least equivalent annual cost. Therefore, the decision will be to replace every 4 years. Replace every 4 years. Every 4 years. This is the end of the solution to the question. In my next video, I will examine the replacement of a component. Please drop the love emoji. Also share the video with others. Thanks for watching ZICA.